Today we're going to see how to factorise this quadratic by the method of completing the square. Before we try this problem, we're going to recall perfect squares. A perfect square is where two linear terms which are the same are expanded to give a quadratic, and so we call that a perfect square. So this would be x plus 3 multiplied by itself. Expanding these terms, we have x squared plus 3x plus another 3x plus 9. X squared plus 6x plus 9. So this is what we call a perfect square quadratic. We can recognise a perfect square if the constant term at the end equals half of this coefficient squared. Now we can see why that happens, because the same values 3 in this case produced two linear terms which were the same, 3x plus 3x. So that's where I come to half of this. I'll write it in this way, x squared plus 6x. Now instead of saying 9, I'll say half of 6 squared. This is the trick to completing the square over here. We halve the value of the coefficient on the linear term, square it, and add it on as a constant. That gives us exactly what we're looking for, a quadratic in this form. Now that we've remembered that, let's go back and try this one. Here I'm using z to represent a complex number, rather than just x for real numbers. Now you might at first attempt think, let's imagine or try to think of two values, two numbers that add to 6 and multiply to 13. Quickly you'll find there are no such numbers that will do this. This is where we move to completing the square. So as we've just seen, divide this by 2, 3, square it, 3 squared is 9. I need to add 9. This part is now a perfect square. Now I can't just forget about the 13, and I can't just forget about the fact that I've changed this by adding 9. So to keep everything equal, I'll immediately subtract the 9, and then I'll write the positive 13, which was already there. It looks a little bit silly to go add 9, take 9, but I'm only going to focus on the first three terms here. This is exactly the perfect square we practiced. As long as we divide this by 2, square it to receive the constant, we know it's a perfect square. So this can be expressed as z plus 3 squared. Now what about these constants? This equates to plus 4. Now we're not really factorised yet because we still have a sum here. This part is squared, and I notice that 4 is the same as 2 squared, but it's plus instead of minus. So I can take care of that by using the imaginary number I. Imagine that this is minus 2i squared. So 2 squared gives me the 4, I squared is negative 1, negative of negative 1 is positive. So if you have a positive constant, you can make a subtraction by introducing the imaginary term, the imaginary number I. Now I have two things that are squared with a difference between them, the difference of two squares. So the pattern for difference of two squares, it will factorise. The first term, z plus 3, goes at the front of each of these. The second term, 2i, and then in the first one we add, in the second one we subtract. And that's how you factorise, by completing the square over the complex number system.